Please could you welcome from Palantir, co-founder, Cohen.
Thank you. So, last year, United States Immigrations and Customs Enforcement agent Jamie Zapata was tragically murdered at the hands of Mexican drug cartels. This tragic death of the agent demanded a swift response, and U.S. Immigrations and Customs Enforcement Agency reached out to a little-known Silicon Valley company called Palantir to look for assistance. The result? Less than a month later, hundreds of people arrested, hundreds of weapons seized, even larger amounts of kilograms of cocaine and methamphetamines seized. If you want to learn more details, you can see the footnote. Fantastic article, as David mentioned, in Wired UK September edition. Highly recommend it. So the question here is, what did Palantir do? What's the story here? Did these brilliant engineers have a hidden mathematical insight, a hidden algorithm that deciphered nefarious acts? What was the secret sauce? So as one of the founders, and having worked on this thing for over 8 years, there's no brilliant mathematical insight that deciphers all of human activity. It's rather we took our brilliant engineers and we built a data analysis platform around one central insight, and that's that humans are fundamentally of a greater order than algorithm. Humans can do certain things that algorithms cannot do. And ultimately, humans have to drive algorithms when analyzing data if the intent is to understand other human beings at the other end of this. So I wanted to talk here a bit about the power of this insight, why it matters, and how big data will ultimately expose this truth even more than it already has in the coming years. So let's start by unpacking this word algorithm. It comes from the computer science lexicon, but it's not that complicated of an idea. An algorithm is nothing more and nothing less than a plan so well defined that there's no ambiguity in its execution. The fact that there's no ambiguity lets machines and other systematic implements execute the idea behind this algorithm very, very fast and efficiently. Where a human being might hesitate to make a judgment, to consider context, the algorithm just ruthlessly executes. This gives it its power and efficiency. And again, the idea is nothing more than a plan so well defined, no ambiguity in execution. But the power of this framework cannot be understated. It underpins so much of what we recognize in the modern world. Look at the Industrial Revolution. So before the Industrial Revolution, the manufacture of goods was really the story of craftsmen using all sorts of different techniques to build things in a different way each time. But the Industrial Revolution, it really came into full force when we recognized there were systematic underlying patterns to this production. We could standardize the form of physical goods, and we could standardize the production of physical goods. Algorithm, of course, the word comes to us because of what we're participating in right now, the information revolution. So maybe we can manufacture goods, but certainly we can't manufacture thought. Of course, the information revolution showed, in a certain respect, that this was wrong. It showed that a subset of thought, what we now refer to as computation or calculation, it could be reduced to simply ones and zeros. And forgive me for erring into the technical of it here, but Boolean arithmetic, right? It's just what a transistor does. And the discovery of the transistor was the leverage that let this information revolution take over so much of what's around us. And it's led up to the moment we're in today. So in many ways, you can look at the entire progression to the modern era. You can look at all of the good that's come from this progression as really just a story. Chart the progress of the modern era as a story of ad hoc human technique being converted to systematic method in the form of algorithm. It's really discovering the systemization of form and function. And this progress of the algorithm, this rise of the algorithm, really is just directly mapped by the rise of the modern era. And of course, here we are, the power of data. We have big data here. I'm just going to concretely define big data since it's a buzzword and it kind of bounces around, means so many different things. Big data, for the sake of this talk, it's the explosive growth of data in both scale and type that we recognize around us as a growing reality. So the question we have here is, well, one, where did this big data come from? In the same way that the algorithm, that this rise to the modern was defined by the rise of the algorithm, by the systematic standardization of form and a function. Well, the algorithm requires the standardization of data as an input, but it also produces more data as an output. So without any headwinds pushing back against it, this forms a positive feedback loop that just loops and loops and forms an exponential explosion in the usage of the algorithm, and that forms a super exponential explosion in the data that's produced. And so this is interesting because the persistent growth of the algorithm in the modern era, its responsibility for most of our economic development, it's always portended this future where perhaps it'll displace all of humanity. What can't the algorithm do? Right? What can't the algorithm solve? And certainly in this exponential growth of data, it seems like the opportunity is now for the algorithm to prove that we might all be out of business here as tech people. Computers might be replacing us sometime soon. This fear, this concern that the unbounded growth of the algorithm will just go on without stop, the positive feedback will result in this infinite expanse of what the algorithm is capable of. This is not the future. In fact, it's actually not even the present. Palantir, like I mentioned at the beginning of the talk, those amazing results we provided were based on a platform to help humans do what humans do best, which is provide the intent, provide definition of the qualitative reality, but of course allow machines to do what they do best, which is the systematic processing of the numbers, the data integration, the quantitative reasoning that underpins human qualitative reasoning. But when you realize that the algorithm has limitations, that the algorithm can't do everything, that it's not magic, then a number of things happen. One, it's not going to displace all of humanity. Humans aren't out of the job, and we're not going to be in the future. The same amazing things that make the algorithm powerful, the same virtues of that efficiency, of that not needing to consider context or quality, just simply quantitative number and simple systematic execution, these are limitations when it comes to certain human affairs. And these limitations bound the potential of the algorithm. So to be direct, what can't the algorithm do? What are these ceilings? Why do they matter? How are they going to affect us? An algorithm cannot directly process qualitative data. What's qualitative data? Hunger, lack of caffeination, fear, happiness, all of those human qualities, these distinctly subjective notions, this is what the algorithm can't crunch directly. Now, what the algorithm can do is, let's say I want an algorithm to tell me what to eat based on how hungry I am. I have to reduce my hunger to a quantitative representation. I could say, take my hunger and put it on a 1 to 10 scale. But the quantization of that quality, it destroys so much. It's shallow. So like, say I'm in a hungry state, I might define it as a 7 out of 10 in hunger. But you can imagine my 7 out of 10 is probably different than your 7 out of 10. In fact, your 7 out of 10 or mine probably isn't even the same from day to day. So when you take these, when you recognize that the algorithm to process qualitative data, remember qualitative data is behind all of the hows, the whys, all of the dynamical aspects of human systems. When you recognize that this, to be usable by the algorithm solely, must be reduced to such a shallow quantitative shadow of the original form, you have to accept that the algorithm has real limitations. So the second weakness of the algorithm is it fails to capture subtle context. This is related to the first, but the efficiency of the algorithm in processing, in solving problems, it comes from everything being explicit and upfront. If I have a complex human situation, I might explain some context to a friend who's entering into it, but I'm not going to explain all of it, and I can't be expected to. This is the subtlety of human intention and human qualities. Algorithms can't capture that. They rely upon the engineers at the get-go to get it in, or any other human in the loop driving it. And fundamentally, the algorithm, kind of in its purest root form, it's trapped in a repetitive cycle. It just does one thing. And no matter how clever the engineering that goes into it, it will repeat that same fundamental process over and over again. So that gap between the fantasy, the utopian fantasy or the dystopian fantasy, the algorithm doing everything, of robots replacing all of us humans, of humanity being put out of all business, especially the human business, versus the reality that I'm saying is happening today, which I'm saying is responsible for the results I showed at the beginning, responsible for my company and for a lot of the other things that are going to happen in the big data space. The gap between that reality and that fantasy, it matters. A lot of things are going to happen where people don't respect that gap. They don't mind the gap. One of the, just to point to a simple example, one of the kind of primary things we're all familiar with where this gap is more or less responsible is the typical stereotype of the broken large bureaucracy. If you look at the stereotype of the big broken bureaucracy through this lens of the algorithm, the story looks like you started with a well-intentioned organization with an important mandate. You added some process to make it more efficient. You then added some more process to make it even more efficient. Pretty soon, you have so much process leading to more process, but there's no governing intent. Nothing unites what this process is doing, and then you have that kind of Orwellian fear of just system after system with no intention behind it. That's the story of algorithms run amok. That's the story of folks forgetting that basically algorithms can do certain things very efficiently, and they should do those things, but humans have to do other things. You don't want to mistake those two. So I want to provide 3 solid takeaways, how we materialize this. So this isn't just an abstract professorial pontification here. So first takeaway, don't hire a computer to do a human's job. Of course, vice versa. The 21st century, we're going to see the algorithm rise to do more than it's done in all centuries combined. But it will only do what it can do. And it's never going to do what it can't do by simple virtue of its definition. And so we need humans. We're never going to have a find the bad guy button. And we're never going to have a make money button. Even if some brilliant engineer finds a little insight, formulates it in a mathematical algorithm, and creates a button that does it, it will only work as long as the human dynamics behind it, as long as the inside of the engineer doesn't change in reality. And the thing about human behavior, especially today in the interconnected age, is it changes fast. So these buttons won't work. The ultimate responsibility for all of these subjective human affairs, it will fall to other human beings. Second point here, the same fundamental tasks that only humans can do, the tasks that rely upon human qualities that defy quantitization, well, those human qualities inside the human personhood, they can only be effectively evaluated by another human. So the standardized test, the algorithmic evaluation of capability, more or less the algorithm will never deduce how hungry I am. It might approximate it, but things change in the human world, and that constantly changing nature means that human quality is ultimately only discernible by other human beings. I personally take this to a bit of an extreme. At Palantir, I still interview every single person. Some of my team can tell you here, it's now up to 45 a week. But this is because of a deeply held belief on the importance of understanding the human qualities that are coming into your organization. And as the algorithm displaces humankind everywhere it can, these human qualities will be paramount, and it's going to become the pivot upon which successful organizations turn. And so when you really think about takeaway 1 and takeaway 2, and you look at where they're pointing, you get takeaway 3 here, which is because humans will be put out of business for all non-human tasks. Basically, everywhere the algorithm can go, it will go, but it can't go everywhere. So when you hire a human, you're hiring those special qualities. You want to make sure you judge the right ones, but then the function of those human qualities in action, that's what we call judgment. It's basically a calculation that has implicit in it fundamental human qualities which seem to defy logic and quantization directly, or aren't purely explainable that way. What this means for organizations concretely: when you hire a human, hire them for their judgment. And once you're hiring them for their judgment, you want to trust them. Trust is the leverage on that judgment. Trust is like the transistor to the algorithm. It's what explodes the power of that human judgment. You want to empower the fringes of your organization, and you want to trust them as much as possible. And if you don't feel comfortable doing this, you probably might as well hire a computer. They're probably going to be able to do it better if you don't trust these human qualities anyways. So thanks, everyone, for listening, and thank you Wired UK and David for having me.
Stefan, we wrote about Palantir. It's a very well-connected company. Peter Thiel, who made his fortune out of PayPal, was in there from the start, is investing. In our piece, we wrote about how you've got projects you're working on with the US government. There's lots of secret projects. Just give us some examples of the sorts of projects that you're working on with your algorithms that can spot patterns in massive petabytes of data.
Yeah, the work I'm personally most proud of is actually our pro bono work. I think probably the most important project is our work with the National Center for Missing and Exploited Children. We help their volunteers take the tips that come in on the hotlines and other data sources and put them together to catch child predators and the children abducted. So again, it's a case where the human mind, the human driver, suspects that something may be occurring and is able to ask the computer to do some of the number crunching for it, but in a way that respects the underlying integrity of the data, the privacy and the civil liberties, but pull it up to that human reason, that special thing, discern the human quality, and then come up with decisive action.
So like the Jaime Zapata case, the software spots patterns that humans wouldn't otherwise spot and draws threads together.
It pulls the quantitative reasoning, which then makes it apparent to the human mind. So if we have to look at this big data without the help of computers, it's hopeless.
Okay.
But just with computers, it won't work either. We do that human-computer symbiosis.
Okay. And I think we also wrote that you were working with financial institutions to try and spot patterns of fraud, for instance.
Yeah. We work with large financial institutions. One of the big things we do is help them understand the real estate holdings. The question of whether or not somebody is, a kind of bad speculator or just, a really honest, good person who's out of work. This is the most important question when figuring out what to do with a mortgage that's overdue. And again, it's a human question, but it's a question that's best answered when you have the data. If you just have a little equation and you have someone at the end of a customer service group just formulating the simple equation, you're going to get bad results. Palantir pulls the data together and then allows that human judgment to do what it does best.
So last question. You've got some of the best data scientists in the world. You've got proven software. You've got lots of people working for you. How many people working there now?
Almost 800.
Okay.
Growing fast if anyone's looking for a job here.
So in terms of spotting the bad guys, in terms of spotting the terrorists, how much of that problem do you think a company like Palantir can solve?
So we were founded on this unique approach of the power of the human-computer symbiosis. Of course, we're Silicon Valley, focused on the most brilliant engineers because we see the power of the algorithm, but we respect its limitation. We don't see too many other people with this approach in the space. And so I think the potential for the company is boundless in terms of putting this approach out there in the world in the form of a wonderfully engineered product platform. But
can the rest of us expect that software will spot the extremists before they hit?
It will help, but it will never get rid of the fundamental role of human reason in that process.
Okay.
Humans will not be put out of business.
Okay.
We'll always have our own place.
There's still room for us, everybody. Thank you very much, Stefan.